G'day, Chris here and welcome back to ClickSpring. In this video, I begin work on probably the most recognised part of the mechanism, the iconic gear wheel known as B1. It's tempting to look at this part and assume that it's a bit like a clock wheel, formed from a single piece of raw sheet stock and then crossed out to reveal the spokes. But look closely at the scan of this wreckage, and you'll see that's not how the part was actually made. There's clear evidence of a dovetail join at the end of this spoke, and in fact other scans confirm dovetail joins at the end of all 4 spokes. In the centre there's evidence of an overlapping notch join, with 4 rivets holding the cross members together to form the 4-spoke shape. This part was fabricated, not cut from sheet stock. And once that fact sinks in, a whole bunch of questions arise. For example, what were the tools available to the original maker to form this part? We know for sure about some of them, like dividers, hammers and files. But were there other tools that we don't yet know about? And what about the dovetail join itself? The maker has confidently applied an engineering technique in a way that suggests complete familiarity, as if it's a standard, well-established practice. Such confidence likely came from previous experience. Were there other similar geared mechanisms that preceded this one? And why go down this much more difficult route of fabricating the wheel blank in the first place? Was it a design requirement, a repair, maybe even a corrected mistake? My personal thought on this last question is that it was probably the same reason that motivates makers today: cost of materials. Bronze was expensive, in fact it still is. I imagine it was far better to reuse the centre cutout for another wheel and then use some off-cut scrap for the spokes, rather than consume expensive fresh stock. But whatever the reason, it must have been a very good one, because this is by no means the easy way to make this part. As per the original device, the cross members will be notched, drilled and then riveted together. And the dovetail joins will be filed to shape for an interference fit with the perimeter ring. A central hole will be bored and of course the teeth formed at the perimeter. Now the scans show what appears to be an amendment to one of the dovetail joins. A thin sheet of bronze has been both pinned and soldered over the top. It could be a feature of the planetarium support structure, but I think it's more likely to be either a repair or a preemptive effort to strengthen an otherwise weak join. It'll be interesting to see if there's an inherent flaw in the dovetail join that requires me to make a similar amendment later in the build. In any case, it's clear that there are a number of challenges to be overcome in fabricating the part this way, the most pressing of which is the issue of alignment. It's essential that the parts be brought back together into precise alignment every time a progress check is made on the fit. The slightest misalignment and the other intersections become compromised. More metal than necessary would be removed, with the result being a poor overall fit. So I'm going to use a simple circular jig to make life a bit easier. The cross members will be located using the centre pin on the jig and an offset pin. The outer ring will be positioned using the register I've turned on the wooden block and a single steady pin on the perimeter. Next up are the 2 cross members that will form the spokes. The raw stock is an offcut from a previous project. It needs to be marked out and then roughed to shape. I use the mill to clean up the raw cuts and also to drop in a reference hole in the centre of each piece to match the central pin on the alignment jig. Now the jig performs 2 functions. Not only does it give me a way to maintain alignment during the filing, but it also works as an excellent platform to help me accurately mark out the work for each step, like for example marking out the 2 notches required for the centre join. Back to the mill and I formed the shallow notches, aiming for a snug fit with the opposing parts. A quick clean-up of the burrs left from the mill, and these two parts are ready to come together and be marked out for the rivet holes. The rivet holes were then drilled while the two parts were assembled, and a set of 4 small rivets turned to size on the lathe. The process of riveting has drawn the two parts tightly together, leaving the rivets just above the surrounding metal surface. From here I can use files and abrasive paper to take them all the way down to that surface, and then blend them into the surrounding metal. Okay, next up, the small alignment pin for the spokes was marked out and then installed in the same manner as the one on the perimeter ring. Now the dovetails are essentially an exercise in freehand filing and fitting, which, as you can imagine, with 4 opposing dovetails has a fair chance of going astray. I'd like them to look reasonably consistent across the part, so I've made a couple of simple tracing templates to give me a fighting chance of getting a good result. And as I make a start on the filing, it's a great time to ask another question. With so much precision handwork, how did the original maker solve the problem of work holding? There's no doubt that a secure method of holding the work would have been essential. So what was the ancient equivalent to this modern screw vise? Filing small parts doesn't usually require a whole lot of force, and the vise also doesn't usually need to generate a particularly high clamping force, just enough to grip the work. So I imagine a simple wooden clamping peg like this could easily do the job, not unlike a modern pin vise. A clamping ring designed to be a sliding fit over the tapered section could be gently tapped into place to provide the clamping force. If it was solidly fixed to a simple bench at a convenient height, I think it'd do a great job, and it's consistent with the known technology of the time. Of course, a lot of the detail of work holding devices like this will probably never be known for certain. But the mechanism has many features that strongly suggest a tool technology that goes well beyond files and hammers. So it's going to be a lot of fun speculating about the nature of that tool technology, and it's a theme that I expect to return to often as the build progresses. Back to the task at hand, I used a saw to remove a small part of the waste stock and then again used files to open up the recesses. And as you can imagine, at this point I was taking the process nice and slow, carefully checking after each change and slowly working towards a close fit. In fact, this is the part of the process where the jig really becomes useful, indicating how much and from where metal still needs to be removed. At the point where I could feel each of the dovetails just click into position, I called the filing complete, and with no further need to check alignment, I tapped out the alignment pins. The spoke assembly was then lightly pressed into position and then hammered home. The part was then mounted on the lathe and taken to final dimension, all ready to receive some of those amazing triangular teeth. Now there's a lot I'd like to talk about regarding the geometry and formation of those teeth. So rather than make this video too long, I'll save that discussion for a later time. But after completing the first substantial piece of the mechanism, it's becoming clear to me that the story of how this machine was made is going to be as much about the tool technology used to make it as it will be about the device itself. Thanks for watching. I'll see you later. Now before you go, and while I'm still on the subject of gear teeth, in the latest Patron Series episode on the Byzantine sundial calendar build, I go through the process of how you can make your own cycloidal gear teeth cutters, something that can literally save you hundreds of dollars on the cost of a project. So if you're enjoying the videos, would like to help me make more, and maybe save a bit of money in the process, then consider becoming a ClickSpring patron. Patrons get the same deal as for the first Patron Series project: exclusive access to the build videos, free plans for the Patron Series projects, and of course the added bonus that one lucky patron will get to keep the finished project at the end of the build. Visit patreon.com/ClickSpring to find out more. Thanks again for watching. I'll catch you on the next video.